So yeah, please let's have a recap of some of the concepts that we've seen so far. So it could be from my session with you on Monday or Aminu's session with you yesterday. Please, what do we remember from those sessions? Hi, Ruben.
Hello, Madam Akosia. Good morning once again. And
Good
to my
morning.
brothers and sisters. Yesterday, we recall over the load balances, that are the types of load balances. And yesterday, we started with network load balancer. And with that, we learned about various protocols. That is, those protocol that belongs to various load balancers. So with network, we got to know about the UDP and the TCP. That is for the network. And we also talk about the gateway load balancer. We talk of the classic one and also how they are connected. That is how the load balancers are connected to various instances. That is what I also recall. Thank you.
All right. Thank you, Ruben. So yeah, we've looked at some load balancing, and we said that it's a service that helps for you to be able to distribute the load or the traffic coming into your application. So thanks to load balancers, you can have multiple servers serving your clients, but the load balancer is going to help give them one point of contact. So instead of you giving out the various server IPs, which is not ideal, you can just use a load balancer and then let it front these various servers, and then these servers will then be able to serve your clients with your clients accessing one destination point. Okay, so apart from the load balancer that you can use to front these four servers, what are the other service that you can also use to give your load balancer a proper, more professional IP address or DNS name? Anyone can unmute and mention the name of the service that we can use to give a proper DNS name to our load balancer so that we don't need to use the default DNS name that comes with the load balancer.
Right. 53.
Yes, please. Thank you. So we saw the four types of load balancers: application, which is what so the protocols that the application load balancer uses is HTTP and HTTPS, which is the protocol that is that serves behind a lot of websites. And we also saw the gateway load balancer, where the traffic coming in takes a detour for some function to happen before it reaches its destination. We also looked at the network load balancer, which we saw that it's faster than the application load balancer. So if you have an application that requires high speed and you want to optimize the performance of your application, a network balancer would be preferred. And it's the protocols that it uses TCP, UDP, etc. And we also looked at the classic load balancer, which we mentioned is was the first load balancer option that AWS started with and is no longer in use. Calvin.
Yeah, good morning.
Good
Good morning,
morning.
everybody.
So we also looked at the SNI, which is the server name indication. We said it solves the problem of loading multiple SSL certificates onto one web server, which can serve multiple websites. And also, it only works for the ALB and the NLB, which now is known as the CloudFront. Thank you.
All right, thank you, Alvin. Yeah, so the server name indication would help for your multiple resources to share share the certificates, and it also helps with HTTP redirection. So if you have traffic that's coming in that is not secure, you could redirect your HTTP traffic to HTTPS by the help of the SNI. Yakubu.
Yeah, good morning.
Morning.
So on Monday we saw scaling. Then we saw the benefit of scaling, and then we also saw the components of an auto scaling group. So we saw that in order to provision scaling, we need the Route 53, we need an elastic load balancer, and then we need a target group. And then we also saw that normally for the load balancer, we attach the DNS name to the load balancer. And then we also saw the benefit of auto scaling, which is fundamentally high availability. Yes, thank you.
Right, thank
And
you,
performance
Yakubu.
aspect. You're welcome.
Yeah, so we can use load balancing to make our application highly available. We can also, it's also a security feature because you're able to have the certificate on the load balancer instead of the individual servers. So it also helps to take some load off your service because the decryption of the certificates would be happening at or will be happening on the load balancer. And an additional way that it helps with security too is that you do not expose your host instance. So we saw that for anybody to SSH into your instance, they need some parameters or some information. Okay, so your public IP address of your server or your instance is one of those things. So it helps, or it's good for you not to expose that. So you could do that through the load balancer's DNS name that is assigned to you automatically. That's one way, which is even still not ideal. A better option would be to use Route 53, which gives you a proper DNS name that you could give to your end users. Dennis.
Okay, so we also looked at a component in load balancing called the listeners. And then said for the listeners, they listen on specific ports on the, what do you call it? The instances based on rules. And then if those rules are satisfied, they'll route the traffic to a specific target group.
All right, thank you, Dennis. Yeah, so still on load balancers, we looked at listeners, and they are always looking out for incoming traffic. So you configure the listener to listen for some type of traffic. You also specify the ports that the listener should be listening on. So whenever end users are trying to access your application through port 80, port 443, the listener would evaluate those rules that you have configured on the listener, and then it would route the traffic coming in to the appropriate server or to the appropriate target group that you have inside of your application. Okay, so today we will be treating Route 53. Let me share my screen so that we start. Come on. Mrs. Perez here.
Yeah, hello, Apostle.
Hi, Perez. How are you?
I'm doing well, sir.
I'm also fine. So we got up to the scaling and name resolution. So please, when you're free, could you please get the rest of them for me?
Okay, sure.
Okay, thank you.
Welcome.
All right. So before we go into Route 53, it's important that we understand what's DNS is. Can anybody tell us what DNS means, the domain name system? Okay, Dennis.
So what I know about DNS is that it converts the what they call it, the string of websites that we see to their respective IP addresses. So google.com, it will convert google.com to the IP address of the Google server.
All right, thank you, Dennis. So the domain name system is what is responsible for converting the string or the letters that we are able to type out. And this system is able to tell which server we are trying to get to, and it would retrieve the IP address of that server and serve us whatever information or whatever web server information is on the websites that we are trying to go to. So for example, if we type google.com inside of our browser address, then the domain name system would be able to map it to some IP address, 172 dot something dot something, and then it will be able to bring us the web page that we are requesting. And Route 53 is AWS's domain name system service, and it helps us to be able to register or transfer a domain name. So if you want to be able to have your own domain name, if you want your users to enter some address and then it brings them to your application or it brings them to your web service, there are domain name registrars that you can use. There's GoDaddy, there's Namecheap, Wix.com also does that. So you can buy a domain name from any of these registrars. Amazon Route 53 is also one of these domain name registrars. So dependent on the domain name that you want or the domain name registrar that you want to go with, you'd be able to get your own domain name that you manage. So whenever your users enter probably yakubuharuna.com. It will bring you to a domain name that you own. It will bring them to a domain name that you own. So Route 53 is has the option where you'd be able to register your domain name with Route 53, and you can also transfer your domain name from another registrar. So probably your domain name was registered with Namecheap and you'd like it transferred to Route 53. This service in AWS allows for you to do that. Another thing it does too is that it helps to resolve domain names to IP addresses. So your users would be entering perez.com or buyshoes.com, but the IP address of the server that will be serving them, you would be able to configure inside Route 53 to route them to that IP address. So when they enter your domain name, it should bring them to a particular IP address that you have configured. You'd also be able to use Route 53 to connect to your infrastructure, and it also helps you to distribute traffic across regions. So when we're looking at load balancers, we saw that by default, it's VPC bound or it is region bound. So you won't be able to route traffic to multiple regions when using load balancers. Route 53 helps for you to take care of this problem. So you'll be able to distribute your traffic across multiple regions by the help of Route 53. And Route 53 also supports high availability and lower latency. You are able to have multiple servers, but because they are all being connected to this single domain name, your users can access these multiple servers through that single domain name, thanks to how you'd configure your Route 53 environment or your Route 53 service. And for lower latency, because you're able to distribute the traffic across various regions, the proximity of your users to the server that is serving them helps to reduce latency. We've mentioned in this class about the difference. I recommended Skill Builder, AWS Educate, and other AWS resources that you can use. And we saw that when we are accessing AWS Educate, it takes longer as compared to Skill Builder. And these are all applications from the same AWS, but due to the infrastructure that is being used to host them or the locations that they are at, we saw that we have different response. We have different response times, or some delay more than others. So that's how we are able to know the effects of latency when it comes to applications. And because of this multi-region setup that you can do, if there's a widespread outage, you would be able to recover from that disaster. So availability zones are about 100 kilometers from each other. So if you should get a disaster that is covering a whole region, Route 53 still has you covered, because with Route 53 you can have a multi-region deployment as compared to just having a multi-AZ setup. Okay. So some infrastructure that you can use Route 53 to connect to EC2 instances, load balancers, S3 buckets, etc. You can also use it to route to infrastructure outside of AWS. All you need to do is to make the record for it and show that whenever the user accesses this DNS name, it should route them to this IP address inside or outside of AWS. It's not limited to just AWS resources only. And it also has the health checks feature where it can be able to tell if your server or the can be able to tell if the server is healthy or not before it would route traffic there. So you can configure it to route to healthy endpoints only. Okay. So using Route 53 with elastic load balancers. By default, AWS assigns a host name to your load balancer, and it resolves to a set of IP addresses, which in this case would be the service that this load balancer is fronting. So okay. So let's so the page that your web server is serving, if you use, let me log into my AWS account. Let's see if I have any instances in the public subnet. Okay. Okay. So I believe we have Nginx installed on this server. This is the server we're using to do experiments, to do demonstrations some time back. Okay, yeah. So we have users would be able to get to your web server by using the public IP address. So when you get a load balancer that fronts the service, they would now be able to use the load balancer DNS to come to the same IP address that's your instance public IPv4 address would have brought them to. So when you configure Route 53 to, it's also going to, and then you make the record that whenever they access your domain name, it should bring them to the load balancer. So this is your domain name, and you make a canonical name record that points this domain name to this load balancer. Let me see if I have any load balancers configured. Okay, I don't have any load balancers. So the default domain name that is given to a load balancer looks something like this. Okay, so your users would be able to use this to get to your website, and they would also be able to use your public IPv4 address to get to your website. But the best thing to do is to use you get a proper domain name from Route 53, and then you map it to the load balancers domain names. Whenever they access this, it's going to bring them to the load balancer, and the load balancer is fronting what?
The server.
Exactly. So it would still, in the end, bring them to this page. Hi, Yakubu.
Yeah, please, I didn't hear what Denny said.
So I asked what our load balancer was fronting, and then he said our service. So the web server, the page that the users come to meet when they are accessing the web server, the load balancer and Route 53 would bring the users to that very same page, but it's a more secure and more scalable way as compared to just giving them the server IP addresses directly.
Thanks.
You're welcome. Okay, so inside of Route 53, there are various ways that you can route traffic, or you can route any DNS queries that are coming in. And the first one is the simple routing. So inside of simple routing, you would associate the DNS name or the DNS record with a specific value. So that value could be your IP address, it could be an endpoint. So even the public IP address that I used to access the web page on our server, you could route that IP address directly to your domain name. So that would be the simple routing policy. Whenever Route 53 gets a DNS query for that domain name, it will respond with that value, which in our case is this. So if we should do a simple routing, for instance, it will respond with the what's it called? With the IP address of our server. So that's so in simple routing, that's more like a one-to-one association. There's also the option to have multiple values associated with the same domain name. So in that case, Route 53 would return all of them, and then the client's device would select one at random. So the simple routing is more straightforward, one domain name to a specific value. So you specify what value it should be, your EC2 server, your load balancer IP, etc. And the next one is weighted routing. So with weighted routing, you assign weights to your various resources. So let's say you have one setup in the US East 1 region, and inside that setup, you have one application load balancer with two servers behind it. And then inside the Oregon region, you also have the same one load balancer with two web servers behind it. You would be able to assign weights to them. So weights in the sense that right now you have two environments, one in Oregon, one in US East 1. So by default, they are all 50% and 50% of your infrastructure. Okay, so you would be able to assign weights to them. So if you want more traffic going to North Virginia, which is US East 1, all you need to do is to increase the weight of it. So you would configure US East 1, your resource in US East 1 to have more weight. So you could give it 90%, 80%, 70%, and then whatever percentage is left, that is the amount of traffic that is going to be routed to the Oregon region. So a use case for that is when you want to do a testing scenario. We'll look at blue-green deployments shortly. You might want to test multiple variations of your website with different user segments. So when you assign those weights, you'd be able to be in control of how much traffic or how many queries are being answered to the various in this case you have two environments, so to your two environments. And the latency routing policy. When you have, is used when you have resources in multiple AWS regions and you want to route traffic to the region that provides the lowest latency. So whenever a query is made, your Route 53 would be able to check to see which region is going to bring the user the lowest latency. So when it does that evaluation, let me still use the North Virginia and Oregon example. So if you're accessing from anywhere in the world, Route 53 is going to check the records to see which region is going to bring you the least amount of latency, and then it's going to route the end user to that region. So that is it with the latency-based routing. And we mentioned that apart from how close you are to the region, some other factors that could contribute to latency could be the performance or the specifications of service that would be serving you. The configurations in Route 53 and those things. So when Route 53 is able to do those checks, it will be able to tell which of your environments is going to give that specific user that is trying to access your app the least latency. And there's also failover routing policy where you would be able to you would be able to configure Route 53 to perform health checks on your infrastructure. So whenever Route 53 detects that there is a problem inside of a certain infrastructure, it would know to route traffic to a healthy one instead of the unhealthy one. So it's typically used for an active passive failover configuration. So when we're looking at one service, was it last week or last 2 weeks? One of you raised the concern about okay, so that they were looking at a multi-AZ setup, and then you raised the concern about the backup or the secondary instance being passive. So we mentioned that it's not yet serving traffic and it's just on standby, so that when something happens to the primary or the main instance, that is when traffic would be routed to that passive instance. And then one of you was questioning how that is highly available. Does anybody remember what service that was? Is Odum in this class?
Yes, Akosia. Yeah, I remember.
Okay.
That was RDS, right?
Exactly. So when we were looking at RDS, that was an active passive setup. So the passive is the secondary database instance that is not yet doing anything, but as soon as something should happen to the primary instance, it would step up to now come and become the primary instance. So a use case for failover routing would be an active passive setup, for instance. So you have a standby instance or you have a standby environment, which is just passive. It's not yet serving any traffic to your users. And then when Route 53 sends the traffic to your healthy or to your primary instance, and then it realizes that your primary instance is not responding as active, then it knows that now it should start routing to the passive environment, making it now an active environment. So that's how failover routing to works. And there is also geolocation routing. So for geolocation routing, for you to be able to configure it, you need to know where your DNS queries are going to be coming from. You need to know where your end users are going to be accessing your application from. And you would then specify some rules on which of your resources should serve traffic to those end users. Gifty helped us understand the last time that's just like how with phone numbers, we have +233 for Ghana, we have +234 for Nigeria, so on and so forth. That's the same way that applications are able to tell what country you are coming from by your IP address. Okay, so if you know the CIDR range of traffic coming from Ghana, you would be able to use geolocation routing to specify that whenever this kind of traffic or whenever this IP is coming into my network, it is this particular server that should serve them. It is that particular server that should serve them. And a good use case for this would be if you have a global application. Feedback. A good use case for this would be if you have a global application that's your web page or your web server is going to have multiple languages. Okay, so you'd be able to route that if the traffic is coming. Sorry, you'll be able to configure that if the traffic is coming from France, then they should access my web page that has been written in French. Okay, and if the traffic is coming from probably England, they should access my web server that has the web page configured in English. So that is one use case for geolocation routing, where you know where your users' traffic, you know where your users' queries are originating from, and then you map them to a specific environment or a specific server inside your environment to serve these users. And there's also the geo-proximity routing. With geo-proximity routing, you are able to route the traffic based on the location of both your users and your resources. So you have resources in a particular region, and so you want the users close to that region to access only those resources that you have inside that region. If they are closer to the Cape region, so if they are closer to the Cape region, you would want them to access your resources inside that region. There's no way your resources in North Virginia should be serving your users who are coming from the Cape region. So the goal of this is to route them to the closest resource available. And it can be configured to respond with your resources located both within and outside of AWS. So it's not only limited to your AWS resources, but even your resources that you have on-prem. You want to look at where the user is, how close they are to your resources, and then you route from there. And geo-proximity has a feature called bias. And what this bias does is it allows you to adjust your routing decisions by shifting more traffic based on changing conditions and priorities. So the bias for, okay, let's take this rectangle, for example, as our map with our locations. Okay, so let's say US West one is here and the US East one is here. So with bias, you'd be able to draw a line. So let's say my cursor is the line that we're drawing. Let me annotate. I think that would be better. Okay. So let's take this as our map. And this is US East 1. Okay. And then this is US West 1. With geo-proximity routing, you have some resources here. And you also have some resources here. Now you have some users here. So make that you. And then you have some users here. And then you have some users here. You would be able to use bias to draw more traffic to this region or this region. Okay, so even though this user is in the kind of in the middle of these two regions, you'd be able to use bias to make sure that whenever he sends any query or whenever he is trying to request for your application, he should be routed here. So you can set your bias to be somewhere here. And then those on this side would be routed here than here. So even though this region is close to, okay, let me use this guy instead. So let's set the bias here. So even though this guy is closer to this region, you'd be able to use bias to draw him here. And a use case for that would be when the resources that you have here are more, the specifications of these resources are higher. Okay, so these resources would be able to serve him faster than the ones here. So let's say you have a Cowbank branch in your area, but when you go there, they don't have a lot of automation. They work really slow. So even though that Cowbank branch is in your area, when you go here, you will be able to get a faster response time because the resources here are more performant. Okay, so sometimes some companies test out applications. We've looked at democratizing the resources when we looked at performance on the well-architected framework. So the company might be trying to test out some resources. And in a democracy, how does it work? You take all of the inputs and then you decide on the one that is best. So probably your company is at a phase where they are testing out various resources and then they would like to know which of them is going to serve them best. So various configurations, various performance levels. In that case, you would have or you could have a less performance environment. At the same time, you have a higher performance environment. So you can use the bias in geo proximity routing to have the users go to a specific environment of yours over another. Okay. And get better. Okay, so there's also multi-value answer routing policy, and with that, you map your domain name or your record to multiple values. So whenever the user requests for whenever the user makes the DNS query, they would be given multiple endpoints, and then the user's what's it called? The user's device. So let's say the client's computer on the client's laptop would pick from that pool of IP addresses that have been provided to the user. So a use case for this is when you have multiple resources that are serving the same content, that are serving the same content. So you'd be able to map your single DNS name to this to these multiple servers, and then whenever the client accesses or whenever the client makes the query, it is going to give your client's device all of these endpoints or all of these IPs, and then your clients would pick from from there. Okay. And there's also IP-based routing. With IP-based routing, you provide a list of CIDRs, the CIDR block. So you provide a list of CIDRs that your clients have, and then you would also provide the corresponding endpoints or the corresponding locations that your client should be routed to. And for IP-based routing, you would need to have all your, what are they called? Your infrastructure guys or the engineers of your application would need to have an understanding of your network, your applications, and your clients for them to be able to make the configurations on which user IPs map to which of your resource endpoints. So IP-based routing would usually be used when you have been using the Route 53 service for a while. So you have enough information that you're able to take statistics and insights about your clients, about your resources, about your network, your application. If you have that much information, you would be able to go with IP-based routing because you'd need to specify what CIDR block your clients might be coming with. And then you map them to the specific endpoints on the specific resources that you have inside your environment. So an example use case is when you want your users from a particular internet service provider to access a specific endpoint. You can configure that by using IP-based routing because you should have studied and known that the ISP's CIDR range looks like this. Probably it has 154 stats in it, or it has some 124 stats in it, and then you'd be able to map every traffic like that to a particular resource that should serve it. Okay, so these are the routing policies. Some of them might sound similar to some, but depending on your use case and what you are trying to achieve, you'll be able to configure these 8 routing policies in a way that they would be able to serve the purpose that you want. Okay. All right, so latency-based routing, it's used when you want to distribute your traffic to multiple regions around the world, and you want your users to be directed to the endpoint that is going to give them the fastest response time. Often, but not always, the region that is geographically closest to the user provides the fastest response times. So this is how it is usually, but I've mentioned an exceptional case or when that is not the case. So when I use the example of Cowbank, so you could have you could be closer to a particular branch, but it doesn't necessarily mean that they are going to be able to get your request done quickly. So those are the few times that this is not the case, but a lot of the time, the region that you're closer to is the region that would be able to give you the fastest response time. Dennis?
Yeah, obviously I wanted to ask this question. Are you able to connect a load balancer to another, like point a load balancer to another load balancer? Because most of the architectures I see, I don't see that kind of scenario or use case.
Okay, so one of the resources that the load balancer is fronting is another load balancer.
Yes.
Let me see. Well, I've not heard of a use case like that, but I think when you start to create, so the page where you have to select your target group, I believe the only option there is instances, containers. Iman, did you see any other options apart from the two that I mentioned?
Apart from, please come again.
Apart from instances and containers.
No, please. I didn't see anything like that.
And so, yeah, so when you get to the load balancer page and you're configuring it, the options that they have there for you, I don't think another load balancer is one of them.
Okay, all right.
Lagos,
Yes, Terry.
yes, for me, I think you can associate like an application load balancer as a target of multiple network load balancers. You just have to register the application load balancer with a separate target group for each individual load balancers. You're going to do that.
Oh, okay. So an application load balancer can be a target for a network load balancer.
Yes.
Okay. Thank you, Terry. Yeah, so this is a use case for Route 53. It's a blue-green deployment where the blue is an existing environment and then the green is the new system or the new environment. And Route 53 in this case is being used to shift users from the existing environment to the new environment. So probably the developers in that company have been able to come up with some improved features, and then they've made some updates that they had to get a whole new environment to be able to host or serve those features. And you have users or clients already on the existing one. So you can use Route 53 to help you to make the move or the shift from the existing one to the new one. So as and when users come in, they would be routed to the new system little by little until all the users would finally be able to route to the new system, and then they would then get rid of, or they would no longer be serving any queries from the blue system. So it helps for you to get insight into the new system that you are using, because as you're moving the users little by little, you could use logs and CloudWatch to monitor that new system. And if there's an issue anywhere, you just need to configure your Route 53 to route the users back to the existing system that they were in already. But if you're able to move them to the new environments without facing any issues, then you can gradually shut down the old system. Because of the potential latency of DNS records, a full shutdown of the blue environment can take anywhere from a day to a week. So it's only when you have been able to successfully move all of them to the new system, and that's when you would look into shutting down the existing blue system. Right, so there's a demonstration about routing traffic to an EC2 instance. I don't have a domain name of my own. So I think we could watch the demonstration instead. Unless Ima, can we use your domain name to
Yes, sure. We can
okay.
use that.
Okay. So this should take us to the documentation on how to go about it. Hey. Okay. Okay, so we already know our domain name, so I would head to the Route 53 service. So we're going to be creating a hosted zone. A hosted zone tells Route 53 how to respond to DNS queries for a domain name. So we have our domain name and we are going to be mapping it to our EC2 instance. Okay, Ima, please, what's the domain name?
Please, I've sent it to you.
Oh, okay. On Zoom.
The chat. Yes, Zoom chat.
Okay. My copy and paste is not like EC2 instance. So oh, okay. So you put it as EYO Ghana test.site, but then the link takes you to Route 53 hosted zone. Okay. So a private hosted.
Is it because hosting it as well? I don't think it should be an issue, right?
Oh, okay. Because when I clicked on it, it brought me here as I'm not authorized to access the resource. Okay, so let's do it to the end and see. If it doesn't work, then we'll just watch a demonstration on it instead. Yeah, so this is a public hosted zone. You use a private hosted zone when you're routing to resources within your VPC. So after you have you've created the hosted zone, you'd then creates a record. Okay, so this is the domain name, and for this record, we are just using a subdomain of the domain name. So EC2 dot the domain name.
The Vodafone lost him too. This girl.
Okay, and we are routing to our EC2 instance. So what value would it be now?
The public IP of the
The public
EC2.
IP address.
Okay, thank you. And what routing policy are we using in this case?
Simple.
All right, thank you. And the time to live, that is how long the page should be cached for your users. So sometimes we visit a site and it creates a cache, or it creates a record inside of our computer or our phone. So if that time to live is about, I think when we came was 300 seconds. So if that time to live is 300 seconds, for the next 5 minutes. So for the next 5 minutes, whenever you request the site, it would not come to Route 53 to come and make a query. It would be serving you what has been cached on your phone or on your PC. And this is done to help reduce the number of requests that users make to Route 53, because every time a user makes a request to your record, you pay for it, and usually you don't change much. So let's say today I've built up a website, and the content of that website is not going to change for a long while. So it's not really necessary that every time a user requests, it comes back to the Route 53 service to come and take that new web page for the user. So it will just use that record or that page that has already been saved for how long you specify. So you can specify from between 60 seconds to 172,800 seconds, which is 2 days. So if let's say you go with this, and then for the next 2 days, the page that's going to be served to you would be the one that has been cached. So that's what the time to live is for. And I think we can just use 60 seconds. And the record type is okay because we're routing to an IPv4 address. Now let's create the record. Okay, so I think anybody can enter ec2.eyo Ghana test.site, and then let me know the page that it takes them to.
I'm getting server cannot be found response.
Okay. Come on, let me edit the record type and see.
Hello, Akosia.
Yes, Sima.
Have you checked the security group on the EC2 instance? Maybe we are not allowing.
Oh, okay, but we were able to access it this way. So I'm sure we are. Yeah, 80 is allowed. Is there what's it called? Certificates on your sites, on your website?
Yes, I have.
Okay, then let me include 440 and see. It's not happening. Let me change the record tab. Let's call it test. And let me use the name server. And go to that. Still happening. Let me just have you guys watch the demonstration. Okay. Hi, Yakubu. What is an example of an AWS infrastructure component that Route 53 can connect user requests to?
Load balancer.
Okay. So load balancers,
S3 buckets.
containers, EC2
S3.
instances,
Instances.
SD buckets. Okay. So the routing policies, the simple weighted latency, failover, geolocation, geoproximity, and multi-value. And Route 53 can help us to register or transfer domain names, and it can also help to resolve domain names to IP addresses. So you have your domain name, and then you create a record, and then inside of that record, the value of the record would be an IP address to your instance, to your load balancer, to your SD buckets, etc. Route 53 helps for you to do this. And with latency-based routing, you can use this DNS system to route user requests to AWS region that will give your users the fastest response. Okay, that's it for Route 53. So we would look at some CloudFront now. 1 second. So CloudFront is one of the AWS services, and its purpose is to quickly distribute static and dynamic web content such as HTML, CSS, .js, and image files to users. It delivers content through a worldwide network of data centers that are called edge locations. So we know that AWS has, with the infrastructure of AWS, there are regions. Inside of the regions, there are at least 3 availability zones, and each availability zone is made of data centers. So inside of that infrastructure, there's also edge locations or points of presence. And these are more widespread as compared to the traditional data centers that the availability zones come with. And it's these edge locations and points of presence that CloudFront runs on. So whenever you are serving content to your users, the request is routed to the edge location that provides the lowest latency. So the whole difference is that if, for instance, this is one region, and then this is another region, the distance between the regions or even the availability zones is quite apart. So what edge locations are is that if you're moving, or in case you should move from one region to another, you could come across a number of edge locations in between them. So the edge locations are more globally dispersed than the regions, and then they are more in number than the regions. So if so being somewhere here, it would take some latency to get here or to even get here. That's if you're trying to access a region. But if it's a point of presence, you notice that it would be closer to you than the traditional or normal regions that AWS has. So how CloudFront works is that whenever a user makes a request, it goes to the closest edge location around the user. And if whatever the user is requesting for is there, it retrieves it to, and then like brings it to the user. But if it's not there, then it goes ahead and goes to the origin. So usually this origin would be an S3 bucket. Well, S3 is global, but you do specify a region. So some content in a region. And please, am I still breaking?
Hello?
Yeah,
No,
it's
I
okay
hear
now.
you.
Oh, okay.
At a point, I think it went off when you were making the drawings, but now it's okay.
Oh, okay. Sorry about that.
Okay.
Yeah, so I'm assuming this is region 1. And then this is region 2. So the edge locations are dispersed all over. So they're more globally dispersed, okay? So whenever a user is trying to access some content that's CloudFront is supposed to be serving, what happens is that CloudFront first goes to the edge location. So let's say the user is here. Let me make that you. So let's say the user is here and then they're trying to access some content. So CloudFront first checks the edge location for the closest edge location to the user for if the content is there. If it is, it just serves the user. If it's not, then CloudFront goes to the region or it goes to the origin. So probably it's usually an S3 bucket that has whatever contents the user is looking for. And it retrieves this to the edge location and then it serves the user. After serving the user, another thing it does is that it caches whatever thing that it went to the origin for. It comes to keep it inside of the edge location. So the next time that the user is looking for it, the user would be served faster than the first time that the user went looking for that content. So examples of the origin, it's S3 buckets, media package channel, and HTTP server like your web server. And you need to configure that is the source of your content. So whenever CloudFront is looking for contents to serve, it knows that that's the source or that's the origin of whatever contents that it is serving. Dennis?
Yeah, I wanted to ask this CloudFront serverless.
Yes.
Okay.
Yeah, you don't make any configurations or any selections on the underlying service. You just define your origin and then you pay for the points of presence that you desire. So
Okay.
probably you know where your users usually are. So you pay for those points of presence or those edge locations that are close to the user.
Okay.
So edge locations and regional edge caches. So because whenever CloudFront goes to the region, it goes to retrieve some information to the edge location, the chances that the edge location content is a lot or is being quite overwhelmed is high because different users are accessing different content. So there are regional edge caches, which sits in between the region and then the edge location. So these regional edge caches, they cache or they keep content that is not so popular. So if the content is popular, your users are usually requesting, it would be at the edge location. But if the excitement or if the demand for that content has gone low, it would be moved to the regional edge cache. So it's still faster than when you have to go to the main region, but it is not as fast as if you're getting this from the edge location itself. So the regional edge caches, let's call them REC, they would sit somewhere here. So REC. Okay. And then they are for caching contents that is less popular. Okay. So in CloudFront's global network, there are more than 450 edge locations. And as compared to regions, we saw that regions are about 24 or 27. But these edge locations are 450. There are more than 450. And there are also 13 regional edge caches, and they are located in 90 cities across 48 countries. So as of 2023, these were the locations for the various points of presence. So for the edge locations. There's one here, one here, one. So we know AWS just has one region in Africa, but then they have 3 edge locations here. And they have, so all the blues we are seeing are the edge locations. And purple is multiple edge locations. So those locations where the users are more, those ones are purple because they have multiple edge locations there. And the regional edge caches, which are not as many as the edge locations, there are 13 of them. So there were 13 of them as of February 2023. I'm sure now they've added more. So these are the regional edge caches around the
Okay.
world.
There is none in the West Africa, only in South Africa and Central or something like that.
Oh, okay. Yeah, the edge locations. So another name for edge locations is points of presence, and they make sure that popular content is served quickly to users. The less popular ones would be at the regional edge cache. And so example of content at the regional edge cache, we have the user-generated content, such as videos, photos, artwork, e-commerce assets, like photos and videos, news, etc. So we know that as soon as something happens, there's a lot of buzz and there's a lot of demand for it. But after a while, whether it's news, a picture, a video, they kind of die down. So that is when they are moved to the regional edge cache because people are not accessing those things as frequently as they were before. So right now they are not trending any longer. So that's when they go to the regional edge cache because you'd have some people still accessing them from time to time. So these edge locations are connected to regions through the AWS network backbone. And we know AWS, the infrastructure is fully redundant and they use multiple Ethernet parallel fiber cables, which are connected globally, and they are linked with tens of thousands of networks for improved origin fetches and dynamic content acceleration. So the key features of CloudFront: security. So CloudFront protects against network and application layer attacks. So the end users do not have access or do not have insights into what buckets is storing the content. They don't have insights into what instance, what web server is serving the content. All what they know is that they go to the site and then CloudFront is able to deliver the content to them. So with network and application layer attacks, CloudFront has, or there's an additional AWS service that you can use to make CloudFront more secure when it comes to attacks like these. Come on. Okay, and availability. So CloudFront helps for your content to be always available because as we saw, the edge locations are quite a lot. So you configure CloudFront in a way that even when your main origin or your primary origin is unavailable, there would be a backup origin that CloudFront can go and get content from. And these edge locations that we saw, they are dispersed all across, and they're dispersed globally, and then they are able to, and they're connected to the regions. So you could have a multi-region setup for your origin, so that whenever the edge location is not able to get content from your main origin, it has somewhere else that it can get content from. CloudFront also offers us edge computing. When we talk about edge computing, it's running code or running whatever process, running it closer to the end user. So the computing is happening at edge and not necessarily, or not happening inside of the region. It's happening closer to the user. And one way of doing this is with Lambda at edge, where you are able to use CloudFront functions to run some functions so that your users can get some capability that they're looking for. CloudFront also offers real-time metrics and logging. You can integrate CloudFront with Amazon CloudWatch so that it would be sending you metrics about your distribution. And it also offers us continuous deployment. You are able to have multiple but separate environments. So with the blue-green deployments that we looked at, for instance, you would be able to roll out your releases or app changes gradually without the need to change your domain name system. CloudFront is also cost-effective. It offers custom pricing, so it's as it's usually done in AWS, you pay as you use. So you are able to make savings with the more edge locations that you want to use. And there's no need for you to pay everything upfront. No long-term commitments and no requirements for professional services. CloudFront is very easy to set up. Just select the edge locations that you want, and you also point the CloudFront service to your origin, where it should be fetching the content from. And AWS offers free data transfer between cloud services and CloudFront. So if, for instance, your content is in an SD bucket, you do not need to pay whenever this content has to traverse the AWS network. So from one point to another, whether it's going over, whether it's crossing regions or it's crossing availability zones, it's free. So having all those factors in mind, CloudFront is quite cost effective to use. Some use cases for CloudFront, it's used to deliver fast and secure websites. And I mentioned that Netflix is one of the companies that use CloudFront because they need to deliver their content, or the content needs to be served to clients as quick as possible. They are also able to accelerate dynamic content delivery and APIs. So the ways that people are able to interface or are able to get your application or program to do something for them, CloudFront helps to accelerate that. It helps to make that quicker. And it's also useful to stream live and on-demand video because of how quick it is. And it's also used to distribute patches and updates. So if you've discovered some vulnerabilities, or you've discovered some, let's say, outdated features in your website or your app or something like that, you would want to use CloudFront to quickly have these patches and to quickly have these patches delivered to the users of the software. Okay. Okay, so this is how CloudFront delivers content to users. So it first checks the edge location. If it's there, it quickly delivers to the user. If it's not, it has to quickly go to your origin, your server, your SD buckets, your social media house, and then go and fetch the content to the edge location, and then it's delivered to the user. Whenever the user should need that same content again, it would give it to them quickly from the edge location, because now it has been cached after being retrieved from the origin. Sorry. As soon as the first bytes arise from the origin, CloudFront begins to forward the object to the user, which makes the process really quick. And it also adds the object to the cache for the next time that someone requests for it. So what are the factors that determine cost when it comes to CloudFront? So depending on which regions that you want to use or which edge locations you want to use, that is what is going to determine if your CloudFront cost is on the high side or not. And the number and type of requests that your users make to CloudFront, that also factors in, because some are more expensive than others. And the data transfer out, the amount of data transferred out of the CloudFront edge locations. So some of the requests that your users make could be GET requests, and that's the request that would require for data to be transferred out. So that's going to make it a direct but when you're using S3, ELB, and the likes, you only pay for storage costs and transfers out to the internet. You do not pay for any data that is transferred between S3 and CloudFront. Okay, where does CloudFront serve popular or frequently accessed content from?
The edge locations.
Okay, and then the less popular ones too, where are those served from?
The region or the origin.
No,
Cash.
The cache.
the REC, the regional edge caches. Yes, so the less popular ones will be served from the regional edge caches, and then the popular ones will be served from the edge caches. Let me say, so content is not served from the origin. What gets from the origin is the edge location. So your clients never have to go to the origin. Okay, it's the edge location and then the regional edge caches that's cool to the origin or the region to get the content. But anything after that is served from either the regional edge caches, which is for the less popular content, or the edge location itself, which is for the more popular content. Okay, so what are some benefits of using CloudFront?
High availability.
Okay, thank you. Number one is the speed. Okay, so
Speed up content review.
thank you. It's also more secure because you're not exposing your web service and your SD buckets to the internet. So I think in the first week, this class, we had Dennis or someone share the sites to a picture in his SD bucket, and then we're able to see. But with CloudFront, you do not need to go, like the users don't need to know about your origin. They just know that they're getting the content from CloudFront. And that is more secure. And also edge computing. So you're able to get some function done closer to the user. And when you integrate CloudFront with CloudWatch, you're able to get real-time metrics. And it also allows for continuous deployment. So as changes are being made to your application on the site, you'll be able to have a blue-green deployment where users can still be active while those changes are being made. And it's also cost effective. And the costs for CloudFront are determined by the geographic region. That is the edge locations that you want to use, the number and type of requests, and the number of data that is transferred out of CloudFront. So CloudFront is a content delivery network service, and it uses edge locations to deliver content securely in a highly available, scalable, and performant manner. It works with other AWS services to help you distribute content to users with low latency, and you don't need to make any initial commitment. So when your build is arriving, then that is when the charges for CloudFront 2 would also arrive. I'm trying to find CloudFront pricing. And how much data is transferred out when the users make the request. Okay, so are there any questions before we bring this this morning's class to an end?
Percent.
Yeah.
Yeah, so this question is not really related, but I just wanted to know whenever you're provisioning an EC to server and you know that the options that says allow SSH and then allow that option that allows you to allow SSH.
Yeah.
If you don't take that option and then you provision that server and then later on you'd want to allow it, is there a way to go back to allowing it?
Yeah, you go to your security groups.
Oops.
Are you talking about this one? This one?
Yeah.
Yeah, you go to your security group. So you select the instance, you go to security, click on the security group. I have 80, 22, 443. So you edit inbound rules and then you add the 22.
Oh, okay. All right. Thank you.
You're welcome. Yeah, so with the CloudFront Python, depending on where which regions edge locations that you want to use. So the number of times the edge location has to go to the region, the price classes. So we have price class 100, price class 200, and then price class all. So the price class 100 just includes US, Mexico, Canada, and then this. And then the price class 200 includes these ones. So if you have knowledge on where your most of your users are, you'd be able to reduce the costs that you incur when you're using CloudFront, because depending on what region you select, your price is going to vary. So when you come to the documentation, it's all here, and you can also use the pricing calculator to give you like the exact thing that is going to cost you. All right, so that's it for this morning's session. I would see you guys in the afternoon for I think serverless and containers. Please, is that okay?
Yes, please. That's fine.
Yes, yes, please.
Okay.
Have a nice day.
You too. Bye.